So friends, moving ahead from equation number 5, which you already seen, is something like this. So from this equation, there is change in your weight vector, that is delta of wk. We have some other points also to be considered from this equation number 5, which would be going on something like this. Now, some points. The first thing is the weight direction. So if you observe, the weight direction is also moving in the same direction as you have your input vector, that is x of k. Next point is the learning rate. So the learning rate, if you observe, is scaled by every iteration. That is, as you increase the number of iteration, the learning rate is getting scaled. That's why we have written eta of k. And the third very important point is your large magnitude vectors. Now, that means when you summarize all these 3 points, we can conclude that this algorithm is becoming a self-learning algorithm, and larger the magnitude weight vectors are not dominating the weight update procedure. That is, even though if we get some magnitude weight vectors wherein we have which are larger, are again what now? They are normalized. They are normalized back to the normal vectors. So henceforth, to make much conclusion on this, moving ahead, we'll try to update, or we'll try to understand how this update procedure works. Now, to understand how the update procedure works, if you observe all the previous equations, one thing, especially if you observe your equation number 4 or equation number 5, one thing which you can observe here is, that is, the change in your x of k is proportional to the change in w of k. That is, both x of k as well as w of k will be changing in the same way. Now, from equation number 3, which you have already seen, we have our E of k. In equation number 3, we have E of k. Now we are writing delta of E of k. So what could be delta of E of k? It is nothing but the previous weight vector along with the present weight vector. So if you observe here, this is just my E of k, which is equation number 3. So to this, what we have done? We have done delta of E of k. That is the next weight vector minus the previous weight vector. So which is nothing but d of k minus x of k transpose into w of k plus 1 minus of d of k minus x of k transpose into w of k. So this is very important. So if you go ahead and simplify this equation, it would look something like this. So what we have done, we have removed those brackets. So d of k would get cancelled. So the end equation which you would get is your x of k transpose would remain as it is with a negative sign. Then you have your w of k plus 1 and your w of k. So both of this w of k plus 1 and w of k are nothing but change in your weight, which is represented by delta of wk. You can observe here minus of xk transpose has been kept as it is multiplied by your delta of wk. Now, however, we also know that delta of wk is nothing but it is w of k plus 1 minus w of k. So if you can observe here, delta of k plus 1 is nothing but the the next weight updation minus the previous weight. And we already know that the value of our delta of w of k. I hope you remember the value of delta of w of k is nothing but we have already deduced from your equation number 5, which just merged your equation number 5. Just go back to the previous slides. You can find out your delta of w of k. So this is how we have written your next equation, which is equation number 7. And finally, we are moving to our last equation. So what we will do is we will try to substitute our delta of E of k and your delta of w of k, that is from equation number 6 and equation number 7. So therefore, we'll substitute the values of delta of w of k from equation number 7, and the next would be from your equation number 6. So thereby it would look something like this. That is delta of E of k is minus of x transpose into eta into E of k into x of k divided by mod of xk the whole square. So here all the other terms get cancelled. The final thing which is remaining is delta of E of k is equal to minus eta into E of k. So what is one thing which you can observe from this equation, equation number 8? The one simple thing which you can observe from your equation number 8 is the right hand side and the left hand side both has your E of k. Now what is that E of k? E of k is nothing but your error. But what we are doing on the right hand side, we are trying to correct the error on the right hand side, which is error correction, and on the left hand side we have the error itself, which is E of k. So therefore we can say that the error correction is directly proportional to the error itself. So this is very important, and this is where we conclude our LMS algorithm. So there are some other points to ponder on it, that is why this is done and all those things. So if we have a small look, what are the different points to ponder on this? So the first point is, here with every iteration we are reducing the error by a factor of eta. So as and when we go on increasing the number of iterations, the error goes on reducing. But by what amount? By an amount of eta. That means there comes the next point. What must be the value of eta? So always, to keep the system stable, we define our eta in the range of 0 to 2. Next, another very important point is the whole algorithm is using error correction, but the third point we have written that it also uses gradient estimate. How it uses gradient estimate, that we'll see in the next classes. Now finally, the last point, here you can observe the last point which I have written. This algorithm is basically used for linearly non-separable data sets. That means, can it not be applied to linearly separable data sets? It can be applied, but if I have a linearly data set, I already have a very good algorithm, which is nothing but your perceptron learning algorithm. One more very important thing, the whole goal of this LMS algorithm is very much different from that of the perceptron. Here we are trying to limit the error, that is, we are trying to reduce the error at the output of the neuron. So friends, thank you for watching this video. Here I conclude LMS algorithm. So if you have any queries, you can always post it to me. Thank you and happy learning.